Example 3. Like the previous two examples, we will analyze the state machine. For the example, we use 1, 2, 3. 3 flip-flop. That means there are 1, 2, and 3 state variables of Q0, Q1, and Q2. Namely, there are 8 states. When Q2, Q1, Q0 is 0, 0, 0, 0, 0, 1, 0, 1, 0, until 1, 1, 1. Okay, 8 possible states that this can be. And the circuit there are 1, 2 external input and 2 output. And the circuit, if you see each output, for example, Z2 is or between this and this from Q2 and Q1, right? And this one Q2 and Q0 prime. Okay, this one. So if you see this equation bubble, this equation bubble, this equation bubble, this equation bubble, you can consider it can be cancelled together. That means the output Z2 equals Q2 and Q1, Q2 and Q1, or Q2 and Q0 prime. This is output equation. And how about Z1? Z1 is what? Is Q0, right? Q0 prime and what? And Q1 prime and Q2. Q0 prime and Q1 prime and Q2. That means output Z2 and output Z1, okay, depend only on state variable. That means this circuit is multi-type, right? Multi-type state machine. Okay. Okay, next. How about clock? Clock. Okay, this is positive edge, right? Clock. Okay, that means each flip-flop will update its value when positive edge. Okay, clock tick. That means when clock tick, Q0 will read data from D0, Q1 will read data from D1, and Q2 will read data from D2 to update each state. Okay, so let's see the detail for Q0. Okay, when clock tick, Q0 will change to new value. Namely, in this case, let's use notation of Q0 star. So when clock tick, right, and this flip-flop will read data from D0. That means Q0 star will be D0. Okay, based on characteristic of D flip-flop. Namely, this one is characteristic equation. Characteristic equation of D flip-flop. And if I want to know the transition equation, that means I must find the difference between Q star and state variable and input variables. So in this case, D0 equal to this signal or this signal or this one, right? Namely q1 prime and x, q0 and x prime and q2 all together. That means equal to q1 prime and x plus q0 and x prime plus q2. This is q0 star, right? So this is transition expression, transition equation for q0 star. Okay, for q1 star and q2 star, also you can find in the same way. Namely, okay, you can find q1 star go to d1 and d1 or with these three product term, and q2 star equal to d2 and equal to these two product term. So now you get output equation and transition equation. So you can finish your analysis. Anyway, for convenience, when you use the result to analyze state transition or output for each state, normally we will write in state output table or state diagram. So because there are 8 states of q2, q1, q0, for 00, 001, 010, 011 until 111. So in this case, when you apply the value of q2, q1, q0 with, for example, 00 into this equation, you will know the value of q0 star, q1 star, q2 star. That means you can fill this table for the value of q2 star, q1 star, and q0 star. Okay, based on this one. Anyway, if you do by substitute value of this into equation, it maybe take time so much. So we may consider something like this. For example, if I consider the value of q0 star, q0 star will be based on this expression is right in sum of product, right? So you may consider when q0 star will be 1, when this term is 1, or this term is 1, or this term is 1, right? That means q0 star will be 1 when what? When q1 is 0, x is 1, right? Or q0 is 1, x is 0, or q2 is 1. So for q1, this term q1 is 0, x is 1. When you see this table, q1 is 0, x is 1, q1 is 0, and x is 1, x, right? X is 1, this one, right? Then q0 star will be 1. That mean this, right? Will be 1. Okay, and this term also this one. Okay, this one. This is for this product term, and this one q0 is 1, x is 0, q0 is 1 right here, right? Here, and here, and x is 0. X is 0 is this. So then Q0 star will be 1 for this, and this. Okay, so you can fill. And the last one, Q0 star is 1 when Q2 is 1. So you can find Q2 is 1. And here, right? Here. 1, 1, 1, 1. That means it's 1, 1, 1, 1. Okay, of this. Okay. Okay, if you use this method, you can fill this table, okay, faster. Okay, so after you complete this transaction output table, you may assign state name. Okay, in this case, I assign A, B, C, D until H. Okay, for state 00 to 111. That means I just substitute this 00 to state A, right? That means every value of 00 that you change to state name of A. Okay? Here, and here. Okay, for another state also. Then you will get state output table completely. Okay. And furthermore, if you want to write down state diagram, for state diagram, you can do also by write down, because this one is more machine, right? So you can write state name and output, okay, in the same circle. Okay, this one B, for state B, output is 1 0. Okay, output is 1 0. For state C, output is 1 0. Okay, for state D, output is 0 0. Okay, and so on. And one more is state change, the condition of state change. For example, for state A, when input is 0 0, okay, put is 0, go to state A. I mean when x, y is 0 0, right? And when x, y is 0 1, go to E. Go to E. X, y equal to 0 1. When from A, when input at clock tick is 1 0, go to B. 1 0, x, y equal to 1 0, go to state B. And when input is 1 1, go to state B. Okay, x, y is 1 1. Okay, you see that okay, when x, y is 1 0 and when x, y is 1 1, okay, also change from A to state B, okay, to reduce number of error. So normally we will write in expression of input condition. Namely, in this case, A go to B when xy is 1 0 or xy is 1 1. X, y is 1 0 or xy is 1 1. So you can write it as x, y prime or x, y. Or you can combine these two terms and reduce to the expression of x variable only. So for the case xy is 0 0, also you can write it as x prime and y prime. And for 0 1, that change A to E 0 1, right? So we can write x prime and y. So the condition that show that the state will change from state A to state B in this case. Okay, for example, when the input condition become true, namely, for example, when clock tick, if input xy is, for example, 1 0, it's 1 0. When xy is 1, x is 1, y is 0, this condition is false. Okay, x is 1, y is 0, this condition is false, right? And together, x is 1, y is 0, this condition become true. So the state will change for these two conditions. Okay? The expression that show the percent to change the state is called transition expression. Okay? Transition expression, okay, to show the state change or the state transition based on the input variables, okay, condition. Okay. So for this one also, at state B, will change B to B when input x, y is 0, 0 or 0, 1. That means when x is 0. Okay, so you can write x prime, okay, at this arrow, okay, to show the state transition from B to B. And from B to D, okay, when x, y is 1, 0 or 1, 1. So when x is 1, right, B will go to D. So you can write the position of x at arrow, okay, to show the state transition from B to D, okay, and so on. And for state E, okay, for example, every input, okay, the state will go to state F. That means it's always true, right? That means it's not depend on the value of x, y. It's wait for clock tick. When clock tick, you change from state E to F. Okay, you change from E to F. Okay. Okay, this is just another method to show the condition of state change or state transition. Okay, next example. There are two input, one output, Z, and two flip-flop. In this case, we use JK flip-flop for Q1 and Q0. So if you want to find out the output equation, okay, again, you just consider this part of the circuit, right? Z equal to this term and this term all together. When this term is x, right, from this x, okay, and Q0 and Q1, and this term is Q0 prime, Q1 prime, and y. So that means output of this state machine depend on both state variable and input variables. So this is mirror type machine, right? Mirror type state machine. And how about state transition? So for state transition, you might find, okay, the relation between Q0 when clock tick, namely Q0 star equal to something that the function of state variable Q0 and Q1 and input XY. Okay. Anyway, for JK flip-flop, okay, you must use characteristic, okay, of JK flip-flop. Namely, you must know the relationship between Q and JK. Okay. Do you remember for the previous maybe your lecture for JK flip-flop. So you know that Q star equal to J Q prime or Q prime Q. So you can use this. Okay, you can apply this relation to find out. Maybe someone may find excitation equation for J and K first, and then apply to characteristic equation of JK flip-flop. Okay? JQ prime plus K prime Q. Okay? For example, in this case, J0 equal to X and Y prime. So you apply X and Y prime right here, and then K is this term or this term, Y and Q1, X and Y prime plus Y and Q1. Okay, all together. This is K. That means when you prime this and Q, right? Q itself. Okay, it's Q0. Okay, so you can determine transition equation for JK flip-flop by using this. Okay, so then by the result you get output equation and transition equation as the result of analysis. Again, from this you can write down transition output table, and after you name each state, fill in binary from to alphabet or name. So you get the output table. Okay. Again, in this case, you can write a state diagram, okay, by using state, by using function expression, okay, to show the condition when the state change. For example, state A will go to A when input x1 is 0, 0. So you write x prime, y prime right here, and A go to C when x1 is 0, 1 or 1, 1. That means just y is 1, right? So you can write A to C by the condition y, okay, and so on. How about the output? Okay, this is mirror time material, right? You can write output at the error. Okay. Anyway, this example field case that output is 1, right? So you maybe write just read logic 1 output. You see, okay? In the state like that, and you write some comment that the error that write nothing. Okay, for the output is 0. That means you write now just read for active, right? Output condition when output is 1. Okay, this is just example. Okay, that's all. And for more exercise, okay, for example, if the problem give you some circuit and let you write down, for example, state diagram. Can you do it? Yes, you can. For example, this one. The first one. You should know input and output and state variable. Okay. For this one, how about input? X not input. No, right? There's no X not input. No X not input. That means the circuit you have just reclocked it. Okay. And the circuit F or next state logic. Okay. The input of circuit F, that's coming from flip-flop or state variable. Okay, and output of this circuit connect directly to output of flip-flop, namely for circuit G. Okay, the output and state field is the same signal or same value. You can imagine that circuit G or output logic is just a wire that connect directly between state variable and output variable. So in this case, I name and the same name Q1, Q2, and Q3. Okay. Then this is a multi-machine, right? And when you analyze, so you just find transition equation. Okay. Namely, this example used the flip-flop, right? For Q1 equals this term or this term, right? And this term is this term or this term, and this term will come from what? Come from Q1 and Q2. And this term is Q1, this term is Q3 okay, and so on. So you can write this, something like this. Q2, Q3 also. Okay. After that, you just fill the state, transition table based on this transition expression. Get into this. So by the result, you get something like this. Okay. When you fill, you just find, as I said, okay, from the previous example. Okay. You just consider when the output is 1, okay, based on the sum of product, right? For example, this term will be 1 when Q1 is 0, Q2 is 1, Q3 is 1, right? So just find out the state Q1 0, Q2, right, is 1, Q3 is 1, 0, 1, 1, okay. 4, 0, 1, 1 is 1, right? Q1 star will be 1, okay. And this term Q1 is 1, Q2 is 0, Q1 is 1, Q2 is 0. So Q1 star will be 1. And this term Q1 is 1, Q3 is 0, Q1 is 1, Q3 is 0, 1, 0, so it's 1 here, okay. So you can find logic 1 to be solved, okay. And for another place that you don't fill is 0, okay. For Q2 star and Q3 star also, okay, you can using this technique, okay, to complete transition table. After that, you can, okay, write down the state. Okay. In this case, I name this state as S0, S1, S2, and so on until S7, okay, state 7. And then you see that this one, the current state is what? 0, when clock tick, we change to 001, right? So we change to this one. And from 001, go to 010, okay? Then from this to this, okay? And so on. So you will get state diagram, something like this, okay? Actually, by the result, this kind of state machine is called counter. Okay, to count, okay, from 0, 1, 2, 3, 4, 5, 6, 7, and back to 0 again, okay, 3-bit counter. Okay, next example. This example let you do something. Let you sketch state diagram for state machine. Okay, let you draw a sketch diagram. Okay, for the state machine whose behavior follow this given timing diagram. So this one give timing diagram with input x and output z1 and z2, right? Okay, this kind of problem you must find state output table. Okay, the complete state output table first. Okay, it's easier than find state diagram directly. And before that, you must define something. Maybe you must define state first. Okay, define what? Define that each period of clock, each period of clock, what is the state? Okay, and then each state you must know two things, namely the output and the next state when completed. So I will prepare state output table in style. Okay, let's consider output. Okay, and here input change. Okay, no clock tick, right? At this point of time. Okay, clock still be 0, right? But input change and output change. That means the state machine should be mirror type, right? Mirror type state machine. And the state will change at positive or negative edge. Can you consider? Yes, you can. Maybe you consider when input is constant, and when clock tick, output change, right? Or here in input not change but clock tick and output change. That means this state machine change at positive edge, right? So now it's just constant only when clock tick at positive edge. So state will change. Okay, now let's start the analysis. At first, because there is nothing right at the beginning, so I will define state A at first. Okay, at the beginning I define state A. State A, what is the property of state A that you should know? From this table, you must know the next state when clock tick. Okay, when clock tick and input x is 0 and x is 1, and the output when x is 0, x is 1. So from this timing diagram, when x is 0, output z is 1 1. When x is 1, output is 0 1. So we can fill this at here, right? When x is 0, output z1 z2 is 1 1, and when x is 1, output is 0 1. Okay, 0 1. Okay, you can fill this. Okay, and then when clock tick, it came to next state. This state x is 1. Okay, you will consider it with this period of clock. When x is 1, output is 1, 0. Okay? Let's state that when x is 1, output is 1, 0 is what? X is 1, output is 1, 0. Okay? It's not A, right? It cannot be A, right? Because when x is 1, for state A, output is 0, 1. But this one is 1, 0. So it cannot state A at here. So you must define new state. I give the state B, okay, at here. So set B at here. The property of state B is when x is 1, output is 1, 0. Output is 1, 0. And now you also know that when clock tick, okay, at state A, when clock tick and input x is 1, is go to B. Change from A to B when x is 1. So you can write state B at here. Okay. Okay. Then this is step B. Okay, next. Okay. Actually, you can continue analysis by using this method until you can complete this step output table. Okay, next. Step B, when clock tick. Okay, go to the state that when x is 1, output is 0, 1. When x is 0, output is 1, 1. When x is 1, output is 0, 1. When x is 0, output is 1, 1. So it can be state A, right? Okay. If it can be the previous present state, okay. So you can use it, okay, to minimize number of states. Okay. So in this case, this one is B. Sorry, this one is A. Okay. B change to A when x is 1. So you can fill this. B change to A when input x is 1. Okay. And then okay, the next clock tick at here. Now x is 0. Okay. Go to the state that when x is 0, output is 0, 0. When x is 1, output is 0, 0. The state that output is 0, 0. Up to now, there is no, right? So you define a new state. A, B, so C. State C. Output is 0, 0 when x is 0 and when x is 1. So now you can fill the next step when for state A when x is 0, right? State A when x is 0, change from A to C. So you can write state C at here. Okay. Okay. State C. Okay. Next. At state C, when clock tick, go to the state that when x is 1, let's go to state that output is 0, 1. When x is 1, output is 0, 1. Okay, it may be state A, right? So you can write A at here. Okay. And also you can fill the next state of state C when x is 1. Okay. X is 1, go to state A. Okay, next. When clock tick at here, and input is 1, okay, go to the state that x is 1, output is 1, 0. X is 0, output is 1, 1. 1. It must go to state B, right? When x is 1, output is 1, 0. Okay, when x is 0, output is 1 1. That means state B, right? It should be output should be 1 1, right? Should be 1 1 here. Okay, this is state B. So now, okay, from now you get this. Okay, go to B is 1 1 here. Okay, next, at state B, when clock tick, let's go to state that when x is 0, output is 1 1. When x is 0, output is 1 1. Or it's maybe what? It may be A or B, right? Okay, it may be state A or state B. Okay. Okay. And when clock tick, when input x is 0, let's go to state that x is 0, output is 1 1. X is 1, output is 1 0. When x is 0, output is 1 1. When x is 1, output is 1 0. 1 0. Okay, that means this statement is cannot be state A, right? Okay, this is state B. That means at state A, when clock tick, x is 0, it's go to B. No, it's go to C, right? That means this one is cannot state A. It must be state B, right? So at state B, when input x is 0, let's go to state B. So you can fill this. At this period, it cannot be A. Okay, now okay, next. Now it's state B, when clock tick, x is 1, state B, clock tick x is 1, go to state A. Go to state A. That means when x is 1, output is 0 1. X is 1, output is 0 1. Okay, okay. Clock tick at here. When clock tick at here, input x is 1. So state A with x is 1, go to state B. Okay. This period should be state B, right? Namely, when input x is 1, output is 1 0. 1 0, okay? When x is 0, output is 1 1. Okay, so state B at here. Okay, A, B. And then when now state B, right? Clock tick. When input x is 1, based on this table, let's go to state B. Okay, continue. Namely, when x is 0. Now, when x is 1, sorry, when x is 1, output is 0. Oh, sorry. Clock tick at here, right? Clock tick at here, x is 1. State B, clock tick x is 1, go to state A. So now it should be state A at here. And then x is 1. X is 1 at state A, output should be 0 1. Okay, 0 1. 0 1 at here. And x is 0, output is 1 1. Okay, so it's A at here. And then when clock tick at here, now it's the A at here. And then at state A, when clock tick and x is 0, A, x is 0, go to state C. State C, output is 0 0. Okay, output is 0 0. Okay, so it should be state C at here. And then now I try to complete, okay, this condition. And then when clock tick, input is 0, right? Input x is 0. At state C, when clock tick x is 0, it's go to some state, right? That what? That when x is 0, output is 1, 1. X is 0, output is 1, 1. And x is 1, output is 1, 0. X is 1, output is 1, 0. Right? It's 1, 0. So it should be state B at here, right? Output is 1, 1 when input is 0. Okay, and output is 1, 0 when input is 1. So it should be state B at here. So it can fill state B at here, right? Okay, maybe. So maybe. Okay, let's continue. Okay, if nothing happened, okay, we should have this complete state output table with 3 states. Okay, but not sure, so we must complete all of this. So at state B, when clock tick, input is 1, so it's go to what? Two states that x is 1. At state B, it should go to state A, right? It should go to state A. At state A, when input is 1, output is 0, 1. Input is 1, output is 0, 1. Okay. When input is 0, output is 1, 1. Oh, it's 1, 1. Okay. So it should be state A here. And then at state A, when clock tick, input is 0. At state A, okay, input is 0. Let's go to state C. Okay, output is 0, 0, right? State C. So it's okay for now. And then at state C, when clock tick, input is 1, right? At state C, input is 1. It should go to state A, right? At state A, when x is 1, output should be 0, 1. 0, 1. And when input is 0, at state A, output should be 1, 1. Oh, it's not 1, 1. So what happened? That means it cannot state A at here, right? It cannot state A at here. So we state that output is 1, 0 when input is 0. No, right? So now you should define the new state A, B, C, D. Okay, it should be state D at here. And the property is when input is 1, output is 0, 1. And when input is 0, output is 1, 0. And that means you should change this one, right, to D. Okay, so when input is 1, okay, change to state D from the previous, this one, C, right? When input is 1, change to state D. Okay, state D, that means when x is 1, output is 0, 1. Okay, it's 1, output is 0, 1. Okay, so that means at state D, when clock tick, input is 1, change to B. So you can write B at here, right? When x is 1, okay, go to B. And the last condition. The last condition. Change to D. Okay. The last one, when clock tick, go to state that output is 0, 0, right? So it should go to state C, right? That means when clock tick at state D, when input X is 0, go to state C. Okay, now you can complete this state output table. Okay, so from this state output table, you can write down state diagram like this. Okay, for example, if you focus just only on state change A to C when input X is 0, A to C, right? When X is 0, X prime, right? And then A to B when X is 1, X. B to B when X is 0, X prime. B to A when X is 1. C to B when X is 0, X prime. C to D when X is 1. D to C when X is 0, X prime. D to B when X is 1, X. Okay. And for the output, okay, you just write down output when X is 0, output is 1, 1, something like this. When X, sorry, okay, for make it clear, this one, right? 1, 1. And when X is 1, output is 0, 1. Okay, something like this. Okay, so you can complete something like this. Okay, in this case, I write down the value of input X right here and output Z1, Z2 on the state diagram. Okay, and the next, example 3, same question but change timing diagram. Okay, at first you must consider that this take positive or negative clock and it is more or mirror. Okay, you should know at the beginning. So for this one, okay, just consider, right here, right? Output change, but input not change, so it's change at positive edge, and okay, we consider output change justly at positive edge of clock, so it should be more time machine, right? So that means you then you can prepare the table in more type machine style. Okay, that means you can separate output column from input column, because output not depend on input. Okay, after that, again you just find the state for each period of clock at the beginning, because there is no any previous information, so you can define state A here. Okay, and consider the property of output and next state. So from now, when X is 0, output is 0, 1, right? Actually, it's not depend on X, right? You can write state A output is 0, 1, certainly. And next, output is 1, 1. So you can define B output is 1, 1 right here, right? Output is 1, 1 at state B. That means when clock tick X is 0, change A to B. Here. And then when clock tick and the state output is 0 1. So it can be state A, right? So if you can use the previous state that already defined, so you should use it, okay, to reduce number of states. So now x is 1, right? B go to A. X is 1, B go to A. Okay. Next, clock tick. Now output is 1 0. Okay, there is no state that output is 1 0, right? So you define a new one, state C. That means when x is 1, A go to C. A go to C. Clock tick at here. When clock tick at here is 0, right? Output is 0 1. 0 1 is A, right? It can be A. So you can fill this. X is 0. C go to A. X is 0. C go to A. Okay. Okay. Let me refresh this one. C go to A. Okay. And then what else? When clock tick at here, output is 1 1. When x is 0. Okay. X is 0, go to B. Okay. B at here. Clock tick at here, output is 0 0. There is no state that output is 0, so you must define a new one, new state D. At here, so B change to D when x is 0, right? Okay. And then when clock tick, okay, change to state output is 1 0. 1 0 is state C. So D change to C when input x is 1. D change to C when input x is 1. Okay. And okay. And this period of time output is 0 0. 0 0 is state D, right? It's state D. So it's D at here. That means when the machine is state C and clock tick x is 1, go to D. X is 1, C change to D. And then clock tick at here, x is 0, output is 1 1. 1 1 is state B. So D change to B when x is 0. D change to B, right? When x is 0. Okay. And then at state B, when input is 1, go to the state output is 0 1. 0 1 is state A, right? Okay. It's A at here. And then clock tick at here, output is 1 0. Output is 1 0 is state C. Input is 1, change A to C. Input is 1, change A to C. Okay. And this clock tick, output is 0 0. 0 0 is state D. Input is 1. C change to D. C change to D. Okay. And the last clock tick, input is 0. Output is 1 1. 1 1 is B. At state D, when clock tick, input x is 0, go to B. Okay. So you can complete this state output table. Okay. Okay. That means you also can write state diagram from this state output table. Because of multi-type machine, so you can write output, okay, in the circle of each state, and then you just write down the condition at state change, right? A to B when x is 0, x prime, A to C when x is 1, okay, B to D when x is 0, x prime, B to A when x is 1, okay, C to A when x is 0, x prime, C to D when x is 1, x, d to b when x is 0, x prime, d to c when x is 1, something like this. Okay? So you can write state, okay, diagram. Okay, and for exercise 4 also, okay, you can use the same method, okay, that you did by yourself. Okay, so okay, that's all for the lecture today. Oh well, before finish that I go to some thing about mini project 1. From mini project 1, maybe everyone already read it, okay, and maybe already understand the problem. Okay, for the problem, let you design a combinational logic circuit, okay, by using any digital circuit simulation. Okay, let's see this detail first. Okay, the circuit will compose with 3 main parts, namely the combinational circuit, okay, and input, right? Input is from 3-bit input. Let's say data input, okay, B3, B2, B1, and B0. And output of the circuit is go to 0 segment. Okay? Use 2 digits of 0 segment. Okay? 2 digits of 0 segment. And there are 3 modes that you must design. 3 modes. The first one, let two more input, right? It is called mode selector, 2-bit, M1 and M0. Okay, to select mode. Okay, M1, M0. So when M1, M0 is 0, this is mode 0. Mode 0 is display nothing. All segment of these 2 digits will be off. Okay, all segments are off. And when you select mode 1 by apply 01, okay, to M1, M0 bit, okay, this is mode 1. You show your student ID on the specified digit. Namely, if I define digit D1, D2, D3 until D10, okay, at your ID, and then if the value of data input is 1 to 10, okay, we show, right, the value of your student ID at the digit that select or specified by this value. Okay, and because there are 10, right? So for the value 1 to 10, okay, we should show something, right? And for 0, we input is 0. Okay, let you turn off, okay, all segment, and for the input 1011 to 1111, or in decimal is 11 to 15. Treat it and don't care, okay, don't care, okay, for the design. Okay, you can uh, include don't care if it can reduce number of variable in the product term when you use Kmap. Okay, something like that. Okay, let's see example. For the student, okay, I've got the idea of this, for example, but for you use your own student ID, right? Not the same of this example. So when it apply 0, 0 for data input, so you turn off all 7 segments. Okay? And when you apply 0, 1 or 1, okay, digit 1 is at here, right? So you show 4 at the same segment. And when you apply 0, 1, 0, 0, 1, 0 or 2, right, in decimal, so you show the digit, okay, the digit 6 at here, okay, on the 7 segment. And you apply 3, okay, 0, 0, 1, okay, you show 5 on the 7 segment. And when data input is 0, 1, 0, 0 or 4, okay, you show 2 on the 7 segment. Okay? And for 5, okay, you show this 5. And when you apply 6, okay, you show 5, okay, and so on, okay, and so on until 1, 0, 1, 0 or 10, okay, you show 6, okay, of this on the 7 segment. This is mode 1. And for mode 2, when you apply M1, M0 with 1, 0, or 2, okay, this mode you display, okay, the value, okay, in decimal, okay, of 2 complement, okay, 3 bit, okay, 3 bit sign 2 complement. For example, if you apply input of 0, 0, 1, 1, okay, or 3, right, so segment show 3. If you apply, for example, 1, 0, 1, 1, 0, 1, okay, 1, 1, 0, 1 in 2 complement, the value is -3, right? So your student segment, okay, must show -3, okay, namely this one, okay, the output have 2, right, 2 digit of 7 segment, right? For -3, show minus at here and 3, okay, at here, okay. And okay, it's just score, right? For the presentation, okay, you must present how to design for each mode, okay, and show the result of each mode. Okay, for mode 0, you turn off all 5%, mode 1 at 20%, mode 2 20%, combination mode. And this mode means if you can use the same input and output, okay, for every mode, so that means you can complete this one, okay, same input switch, same output, okay, of 2 digit of 0 segment, okay. And for the report, okay, just to show the design, right, how to design, okay, maybe use Kmap or some of your idea that you use to the design, okay, write it clearly and summarize, okay, number of logic gate that you use, okay, and summarize the problem that you found and how to solve the problem, okay, and needed of your report, okay. This is 20%. okay, and the last 20% is percentage, okay, by record, okay, video clip, okay, maybe actually it's not limit time, but usually maybe not, it should not over one hour, okay, or 1 hour and a little bit minute is okay. Okay, and for the detail, okay, for the detail, actually you just follow your report, okay. That means at the beginning that you introduce yourself and let you show your student ID or citizen ID or some passport that show that it's yourself, right? And then, okay, during the review record, you should show your face, okay? Sometimes, not to all of the time, okay? To confirm that this face and this voice it's the same person, okay? To show that you do it by yourself, okay? That's all. And then you explain, okay? Follow this. And after that you just upload maybe on YouTube, okay, if possible. And if possible, let you specify timestamp also, okay. It's easy for me, okay, to see the detail for each part. Okay, that's all, okay, for the detail of mini project 1. Okay, and I will introduce you just for some software, okay. Actually you can use any software to simulate, okay, but one of them that maybe everyone can use, maybe this one, okay. This is logic sim, okay. You can search by Google and then you can download it, okay. You can download it, okay. And this software you can install in Windows, in Mac OS or Ubuntu, okay. Any OS, okay, can install, okay. Install free, okay. If your computer have no Java, maybe you should install Java first. After that, okay, when you download it, okay, you can run, okay, and the program suddenly, okay. Need not to install anything else, okay. When you open the program, you will see something like this. Okay, when you use this one, for example, okay, there are something like this. Wiring, gate, pressure, arithmetic, memory, input output base, okay. For this conventional circuit design, maybe you can use just gate, wiring, input output, and maybe pressure. That's enough. For example, for gate first, okay. Inside this there are many types of logic gate, right? For example, I select AND gate, okay, this one, AND gate. By default, maybe show 1, 2, 3, 4, 5 input, 5 input. So maybe you can change number of inputs at here. If you use only 2, so you do change 2. So 1, 2, right? And actually you can label on it. For example, A1, for example. So name of A1, something like this. And I select OR gate right here. Okay, and I change this one to input, something like this. And you can change the size, right, of logic gate, narrow, medium, or wide, and then you just connect. Okay, for connect it is easy, right? You set broad line directly, something like this. Okay, connect to some input. Okay, for the input output, you can select from this. Okay, right? Okay. Anyway, actually you can use this icon, add pin. Okay, this is input, right? And this one just show maybe output. Okay, let's use this one, and then connect this one, this to this, and this to this. And for the output, let I connect to LED, for example, to this one. So if you want to simulate, okay, you just select enable, right? Enable, and now this is just for change the value. You click it, right? Click this one. Okay, now it's turned on LED, right? If it's logic 0, it will be dark, okay, green. And when the logic of the signal is logic 1 or high, it change to bright, okay, or light green, something like this. For the detail of the meaning, you can see in the help in the tutorial or user guide. Okay. And for example, if I want to show, okay, on certain segment, you can use something like this. Okay, and if I want to connect to some segment, okay, if you don't know that it will show segment add, okay, for example, I give this one to this pin, and when I turn it on, oh, this one A, B, this is B, right? Okay, I move, okay, I change here, select this one and delete, and change it here. Okay, it's A, B, something like that. A, B, C, D, E, F, G. Okay, you can select. And okay, something like this. And someone maybe use multiplexer, right? If you want to use multiplexer, you can select from this one, multiplexer. For multiplexer, select bit is 1, that means we will have two address, right? 0 and 1, right? Data bit size is 1, something like this. You can change data bit size and include enable, yes or no. Enable mean if you want to use this one, you must give logic 1 at enable. If not, there's no any output. Okay, go out. If you don't want to use, you can change to no, so it's absent, right? And you have accessory selector pin, and for selector, this one, we select this one. Now selector bit is 1, you can change to 2, okay, maybe as M1, M2, okay, for your mini project. When you change to 2, so it's 1, 2, 3, 4, right? 4 bit 0, 0, 0, 1, 1, 0, and 1, 1 address. Okay, so for example, if I use more 2 bit, okay, or 2-bit to the selector. But the problem is, for this one, you have got only one wire, but your input is 2-bit, right? If you can you connect it directly, it's not okay, because now you define this is 2-bit, but this input just 1-bit. Okay, if you use 1-bit input, so you can use this one, which one, splitter, this splitter to split. First I must rotate, okay, to change the direction. Okay, you can select this one, facing, to face in north direction, south, east, west. Okay, anything. Okay, let's use this one and define. Okay, define. Now fan out 2, right? Bit width is 2. Okay, maybe it's okay for now. Okay, to split. So you can connect these 2 second bit to this 2-bit bus, okay, or of this multiplexer. So the output also, okay, for this case output is 1-bit, right? 1-bit, 1-bit, 1-bit. Okay, data bit is 1. So that means you can use this one just with 1-bit. And then for this value, you can define by use this pin, right? This pin. Okay. Something like this. Actually, okay, this pin, just for example, right? Or someone, actually you can define this not only 1-bit. Actually you can define it at 4-bit, for example, 4-bit also. That means the output will be 4-bit. So if you want to connect to this one, you may use this splitter. This splitter, and then change direction to this node, to this node, to this node. Which one is better? I'm not sure. Okay, maybe this one. And you define that fan out is 4. Okay, with maybe also 4. So then you can connect this to this together, and then connect this one. Okay, so when you want to change, just click, right? Select this. Okay, put this one. Okay, this one is here. And if I select to address this one, so this one, right? 0, 1. Okay, this input will go to the output and make this segment turn on. Okay, just for example, if you want to zoom in, zoom out, you can change it here. Okay, right here. Okay. And if you want to know anything else, you can go to help. Okay. For example, if you want to know about 7 segment, so for 7 segment display, something like this, right? We have the detail about this. Okay. About pin. Okay, this, can you see? This is segment A, right? segment A connect to this one, B at here, this one B. This is segment A, B, this one is C, D, E, F, G, and dot point at here, for example. Okay. Okay. I hope you can use this one. Okay. For mini project one. Okay, that's all.